Welcome to IT.Solution, your total network, system, firewall, and security partner.
Welcome back to The Explainer. Today, we are diving into what is literally the lifeblood of modern Cisco networks, DHCPv4. We're going to look at the source material to demystify exactly how this works behind the scenes. So let's just get right into it.
Think about this for a second. You walk into a coffee shop, you tap the Wi-Fi network, and boom, your phone is online. But how does it instantly know its IP address, the subnet mask, the default gateway? I mean, scale that up, right? Imagine you're a network admin and you have to manually type in static IPs for, say, 500 computers across an enterprise campus. It would be a complete nightmare, spreadsheets everywhere, typos for days. Thankfully, we've got an automated hero that swoops in to solve all this seamlessly, and that's DHCPv4.
Okay, let's dive into this roadmap. First, we'll look at the magic of DHCP4. Then, the DORA process explained, configuring the DHCP server, overcoming boundaries with DHCP Relay, and finally, the router as a client.
Section 1. The magic of DHCPv4, automating network access.
So looking at what makes automatic IP addressing so essential, it really goes way beyond just saving you some typing time. It operates in this client and server mode, dynamically feeding clients the critical config info they need to actually communicate. But here's the absolutely crucial concept. DHCP doesn't just hand out IP addresses permanently. No, it leases them. By temporarily loaning out an IP from an available pool, it allows for true network mobility. When a device disconnects, that lease expires, and the server snatches the IP right back to use again. It's an incredibly efficient system.
Section 2. The DORA process explained, a network conversation.
Now, how does this actually play out behind the scenes? It happens in the literal blink of an eye, but it's actually a highly structured network conversation, and this brilliantly illustrates it. When a client boots up and wants to join a network, it's essentially begging for an IP address. Since it doesn't have an IP yet, it uses a broadcast message to just shout to the entire local network, basically hoping a server is listening. The server hears this, graciously offers an address, the client formally requests it, and the server acknowledges. It is a very polite, four-step back-and-forth exchange.
The absolute easiest way to remember this is the mnemonic DORA. D-O-R-A. First, the client broadcasts a DHCP discover message. Second, the server replies with a unicast DHCP offer offering up a lease. Third, and this is key, the client broadcasts a DHCP request to explicitly accept that specific offer. It broadcasts it so any other potential servers know their offers were politely declined. Finally, the server sends a unicast DHCP ACK to finalize the whole shebang. Discover, offer, request, acknowledgement. DORA.
But wait, what happens before that lease expires? Does the client have to do that whole four-step DORA dance all over again? Actually, scratch that. It's a lot simpler. Renewing a lease is a much shorter two-step process. Because the client already has an IP and knows exactly who the server is, it just sends a direct unicast DHCP request to that specific server asking for more time. The server then replies with a DHCP ACK. Just a quick request and acknowledge, and boom, the client is good to stay online.
Section 3. Configuring the DHCPv4 server, putting it into practice.
All right, let's transition from the theory side to the actual Cisco command line application. There's a very specific, logical workflow you want to follow to turn a Cisco router into a fully functional DHCPv4 server. Step 1. Always exclude your static IPv4 addresses first. You do not want to accidentally hand out an IP that's already assigned to a router, a switch, or a printer. That's a huge headache. Step 2. You create the DHCPv4 pool and give it a name. And Step 3 is where you actually define the network parameters that are going to be handed out to those clients.
So the crucial point here is mastering the specific syntax that builds out that pool. Once you enter the IP DHCP pool command with your chosen name, you drop right into DHCP configuration mode. From there, you use the network command to define the range of available addresses and the subnet mask. You use the default router command to tell clients where their gateway is. You can also toss in the DNS server and the domain name. You can even use the lease command to change how long the lease lasts from the default, extending it to days, hours, or, even making it infinite.
Of course, configuring it is really only half the battle, right? You need your troubleshooting toolkit to verify it is actually working. The show running config pipe section DHCP command is fantastic for just quickly checking your configured parameters. If you want to see exactly which MAC addresses have been assigned which IP addresses, you use show IP DHCP binding. And if you're troubleshooting the DORA conversation itself to see if messages are even making it, show IP DHCP server statistics will give you the exact counts of discover, offer, request, and ACK messages sent and received.
Section 4. Overcoming Boundaries. The DHCP Relay Agent.
Now, here is where we hit an interesting plot twist in network design. Because the client's initial DHCP discover is a broadcast, and we know routers block broadcasts by default, the whole system completely breaks if your centralized enterprise DHCP server is sitting far away on a different VLAN. No way around it. To fix this conflict, we have to configure what's called a DHCP Relay Agent. By applying the magical IP helper address command on the router interface connected to the client's local network, the router actually intercepts that broadcast, bundles it up into a directed unicast packet, and routes it directly to the central server. The server replies back to the router relays it to the client, and problem solved.
Let's move to Section 5, the router as a client, switching roles.
Building on everything we've seen so far, we've spent this whole time looking at the router acting as the big boss, the server handing out addresses, or the relay agent facilitating them. But what if the router itself needs an IP address? This is actually incredibly common in small office or home office setups. In this scenario, the router connects to an ISP, an internet service provider, which dynamically hands out public IP addresses. So on the Cisco router's WAN interface, instead of typing out a static IP, we simply enter IP address DHCP. The router instantly flips roles and becomes a DHCP client, asking the ISP for its configuration.
This perfectly illustrates just how flexible Cisco hardware really is. On the internal LAN side, your router is likely acting as the DHCP server, dynamically feeding IP configurations to all your local PCs, phones, and whatever else. Meanwhile, on the external WAN side facing the internet, that exact same router is acting as a DHCP client, receiving its own IP config dynamically from the ISP. It is literally playing both sides of the DORA process at the exact same time. We've covered a ton of ground today, from the DORA process to server config and relay agents. But I want to leave you with a provocative thought about network security. If a client is just blindly shouting a broadcast out onto the network saying, "Hey, I need an IP address and a default gateway," what exactly stops a malicious rogue device plugged into a wall jack from answering first? What if that rogue device gives the client an IP but lists itself as the default gateway so it can steal all your traffic? Think about that vulnerability for a second, because it's exactly why advanced security features like DHCP snooping exist, and that is for sure something you should be.
Thank you for watching. See you in the next episode.